We're going to go over some review of some basics of factoring and what factoring is. So there's some vocabulary that you need to know. You need to know what a factor is. Factors are numbers that can be multiplied to get another number. So for example, 4 has a factor of 2 and 2, or 4 and 1. You can multiply 4 and 1 together to get 4, and 2 and 2 to multiply together to get 4. A greatest common factor is the greatest factor or the largest factor that 2 or more numbers share. So if we're talking about, say for example, 8 and 4. We're looking for the biggest number that can go into both of them. So obviously 4 can go into 4, and 4 can also go into 8. So the greatest common factor for them would be 4. Prime factors are numbers that only have numbers or factors that are itself and 1. So for example, 11. 11 is not divisible by any number other than 1 and itself. So if it has just 1 in itself, it's called prime. Composites are the other numbers that have more than 2 factors. So for example, 8. If we do 8, we have factors of 1 and 8. That makes 8. 2 and 4. That also multiplies together and makes 8. So it has more than 2 factors. The number 1 is neither prime nor composite, and there's a lot of controversy over that, depending on who you ask, but that's what we're going to go with, that it's neither a prime nor composite. So we're going to talk first about some things you probably did long ago when you found out factors, when you started thinking about what numbers can multiply to get you a number. So we're going to do the factors of 84, and this is one method you might have seen before. I call it the rainbow method. You take the number, we know that 84 times 1 is going to get us 84. So I do 1 here and 84 here. Then I think, well, what about 2? 2 times what will get me 84? Well, 42. Then I think about 3. Well, 3 times something get me 84. So 3 times 28. And then I go up to 4. 4 times something get me 84. 21. And then, will 5 work? 5 can't go into 84 evenly, so that won't work. Well, what about 6? 6 times 14 will get me 84. Think about 7. 7 and what will get me 84? 7 and 12. And I notice if I go to 8, it won't work. 9 won't work. 10 won't work. 11 won't work. And then I start repeating at 12. And you might have seen something like this where they did 7 and 12 connect, 6 and 14, 4 and 21, 3 and 28, 2 and 42, and 1 and 84. So it's like a rainbow factoring. Probably saw that in like 5th grade. Now, you also have to think about what prime factorization is. So prime factorization is taking a number and factoring it down to its prime numbers. So we start and we use what we call a factor tree. And we think of 2 numbers that can multiply together to get me 84. And I can start with any 2 numbers. I don't really want to start with 1. Obviously, that's not going to be helpful. But any 2 numbers that multiply together. And we can look back up into our beginning. But I'm just going to pick, like, say, 3 and 28. Now, notice that 3 is a prime number. It can't be factored any further. But I can factor 28 further. So I can think about what 2 numbers multiply together to get me 28. And my goal is to get these down to prime numbers. So I'm thinking about prime numbers that get 28. I can see 7 and 4. So 7's a prime number. And I'm circling my prime numbers because I know I'm done factoring those. 4 can still be factored further. And I can think about those 2 numbers, 2 and 2. So now I have it down to all prime numbers that are circled. So that means that 3 times 7 times 2 times 2 will get me back to 84. Now I can write this, instead of this out, I can write this as I have 2, so 2 to the power of 2 times 3 times 7. Okay. So here's another example of doing 200. So I want to start with 2 numbers that multiply to 200. I'm going to start maybe 10 and 20. Well, neither one of those are prime. They can further be broken down. So let's break down 10. 2 and 5. Well, 2 happens to be prime and 5 happens to be prime. Let me try 20. 5 and 4. Well, 5 is prime. 4 can still be further broken down as 2 and 2. Now I have all the prime numbers. So I would have 2 times 5 times 5 times 2 times 2. And instead of leaving it like this, I have 3 2's, so 2 to the power of 3 times 5 to the power of 2, because I have 2 5's. So that's kind of some review based on what we've done before. So now how does this factor into algebra? So let's start with this first example. We have 45, x to the third power, and y to the second power. So we're going to think about what is the biggest number prime factorization-wise that I can break this 45 into. So it's like using our factor tree. So we're just going to look at the number individual first, and we have 9 and 5 equals 45. 5 is prime. I can break down 9 further as 3 and 3. So I can write my numbers there as 3 times 3 times 5. Now let's look at our x's. What x to the third power is really saying is x times x times x. What y to the second saying is y times y. Okay? So if I'm going to write this as a prime factorization fully in this manner as completely primed, I'm not going to write it with the exponent anymore. I'm going to write 3 times 5 times x times x times x times y times y. Okay? All right, so now let's see about how we know how these are broken down and what actually makes up these numbers using the greatest common factor. So this is what you'll be using when you're factoring and we move through our units with factoring trinomials and quadratics. So we have two numbers here. And on a subsequent video, I'm going to show you how to use your calculator and Desmos to help you find greatest common factors of numbers or even just factors of a single number. So we're going to look at our numbers first. So we're looking for the biggest number that we can take out of both of those. Now I'm going to use prime factorization here to help us to kind of show us this one the first time, but then after that we're going to do a quicker method, what you'll actually use when you do this for real. So when we think about this, we already know 45, x to the third, y to the second. We've already done that one up there. So I'm just going to copy it back down here. 3 times 5 times x times x times x times y times y. Okay? Now, we're going to do the same thing with 60, and we're going to prime factor it. So 60, we can think about 3 and 20. 3 is prime. Let's break down 20 further. We have 5 and 4. 5 is prime. And then 4 breaks down to 2 and 2. So for this one, we have all our factors. And then we have 5 x's and we have 3 y's. So I'm going to write it right underneath my original problem. I'm going to use a different color for this one. So we're going to write 3, 5, 2, 2. And I have 1, 2, 3, 4, 5, and 1, 2, 3. Now, we're going to look and think about what matches up. So if I look here and I say, well, I have 3's that match up. I have some 5's that match up. I don't have any 2's. I have an x, 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 and then I have my y, and I have another y. So what we have that matches up is going to be the greatest common factor for both. So I have a 3, I have a 5, I have 3 x's that match up, and I have 2 y's. So I could write this as 3 times 5 is 15, x to the third power, and y to the second. So this is breaking down kind of how this works. So now let's get into some application. Obviously, you don't want to draw this every single time, but it's there if you need to kind of help you. So let's look at B. So this is why knowing your multiplication facts are very important, and knowing factors are very important of numbers that make up or multiply to get a number. So we're going to look at our numbers first. We're looking at 12 and we're looking at 90. And we want to think of what is the biggest number that can go into both. Well, 12 can't go into 90 evenly, so we can't use 12. So we think about what's our next factor for 12. So, and I think about quick factors. I can think about 1 and 12. I can think 2 and 6, and 3 and 4. Well, we know 12 won't work because it won't go into 90 evenly. So my next biggest one's 6. Well, will 6 go into 90 evenly? Yes, it will. So 6 is our greatest common factor for these two numbers. Now we're going to look at our variables, our a and our a. Well, our first term has a squared, and our second term has a squared. So out of both of them, we can pull out an a squared. Now let's look at our b. We have a b to the first power here and a b to the second power here. Well, I can pull out one b, but I can't pull out two because this term here does not have two. I can only pull out one b. So my greatest common factor for these two terms would be 6a squared b. All right, you try C and D. Pause and then see how you do. All right, for C, we have 7a cubed, b squared. And for D, we had three terms. You have to look at all three of the terms and find the largest number that can come out of all of them. And then look at each individual variable. Now, when you look at the variables, one of the things that you can kind of remember is you're trying to find the greatest common factor for each variable. It's really the lowest exponent of each monomial. So notice this x was to the 5, x to the second, and x to the 10th. Well, the lowest one was x to the second. That's all I can pull out. All right, let's try a 3-star. We have 96y, 24x, and negative 8y. A lot of times people get confused with the negative 8. Remember, this is the same thing as negative 1 times 8, and then the y. So think about it that way. So what's the largest number I could pull out? I don't have any variables. Only thing that I could pull out of this one is 8. I always like to look at my smallest number and say, okay, I know 8 can go in itself. Can it go into 24? Can it go into 96? And that's a quick way to find out. All right, so our procedure, we're going to find the greatest common factor of the numbers first, and then you're going to find the greatest common factor of each variable. And a little hint there, the lowest exponent of each monomial term is that greatest common variable.